Okay, let's dive into this. Welcome to today's explainer. Look, if you've touched any modern technology today, you've already interacted with deep learning. It's literally everywhere. But getting past all those flashy buzzwords, how do the actual mechanics of these systems operate under the hood?
Let me ask you this. How does a car actually drive itself? I mean, really think about it. How does a machine instantly know the difference between, say, a shadow, a pedestrian stepping off the curb, and a stop sign, all while navigating a totally chaotic city street? Honestly, it feels like magic, right? But it's not. It's actually a highly sophisticated layered system working flawlessly behind the scenes. And that points us straight to the core mystery of what powers modern AI.
Section 1. What exactly is deep learning? Let's unpack this.
At its very core, deep learning is powered by artificial neural networks. Now, these are architectures heavily inspired by our own human biological brains. Instead of just blindly following pre-programmed rules, they actually ingest massive, totally unstructured datasets. They identify these deeply hidden, complex patterns entirely on their own. And you know what the real power is here? They improve over time. Yeah, the more data they process, the sharper and absolutely more precise their predictions become.
Moving on to Section 2, let's look inside the neural network.
Now, what's really interesting about this is how these networks process information. It's basically a ladder of comprehension. Okay, so in step 1, the system inputs raw data. Think individual pixels in a digital photo. Then, by step 2, deeper layers start combining those pixels to recognize simple stuff, shapes, lines, edges. And then, by step 3, it synthesizes all those basic patterns to understand highly advanced concepts. It literally transforms thousands of raw, meaningless pixels into a recognized face, a sprawling landscape, or even nuanced language. It builds comprehension step by step.
Section 3. Traditional machine learning versus deep learning.
The leap here is, well, it's absolutely incredible. See, in traditional machine learning, data scientists had to do all the heavy lifting manually. They had to tell the system exactly which features to look for before it could even start working. But deep learning, it completely rewrites the rulebook. It automatically extracts the most important features directly from unstructured data, zero hand-holding required. This entirely eliminates that old manual bottleneck, allowing these systems to scale almost infinitely and learn from raw information on a scale that was, frankly, previously impossible.
All right, Section 4, Real-World Applications. So these are the underlying engines powering the tech we all rely on constantly. Take image recognition. That's what groups your family photos instantly on your phone. Or speech processing, which allows your smart speaker to actually hear and parse your complex commands, even if you're in a super noisy room. Then you've got recommendation systems mapping out your highly specific behavioral patterns to predict your exact next favorite movie. And of course, natural language understanding, which enables computers to converse with us in ways that feel incredibly human and context-aware. But the impact goes way beyond just our personal devices. In healthcare, deep learning is out there detecting microscopic anomalies in medical scans to drastically improve diagnostics. Over in finance, it flags complex fraud patterns in literally milliseconds. It's totally revolutionizing customer service through highly intelligent automation. And, getting back to our initial question, it is the absolute backbone of autonomous driving. I mean, it can instantly calculate the trajectory of a swerving cyclist in the pouring rain. Basically, it's all about automating really high-stakes decisions at a massive scale.
Section 5. Let's move to the engine room and see how this all builds together.
And this brilliantly illustrates what's going on behind the scenes. You really need a perfect pairing of raw computing power and structured software design. On the hardware side, specifically GPUs, well, they are absolutely essential because they handle thousands of complex computations simultaneously. But raw power needs direction, right? That's where AI frameworks like TensorFlow and PyTorch come in. They provide developers with the structured tools needed to build these complex architectures. It's exactly this specific combination, bleeding-edge hardware and streamlined software, that actually makes training these massive deep learning models possible.
And finally, Section 6, Shaping the AI Future.
So, the crucial point here is that deep learning isn't just some passing trend. It is actively shaping the future of our global infrastructure. It enables the creation of significantly smarter systems that can continuously adapt to totally new environments. It provides this resilient, nearly flawless automation for incredibly complex tasks. Ultimately, it drives advanced, instantaneous decision-making across every major industry on the planet. Really, it is the core engine pushing our technological progress forward.
I want to end today's explainer by leaving you with this one thought. As deep learning continuously improves, and as it automates more and more complex decisions every single day, how much of your daily routine will soon be managed by a neural network? Think about it. From your morning commute to your medical care, this integration is really only just beginning. Keep asking questions and keep learning.